Understanding asyncio.Future and task execution in Python. Introduction. When working with Python's asyncio, you might find it confusing that awaiting a future object seems to run a coroutine task tied to it. What actually happens when you await future, and why does a task seem to start automatically? Let's clarify these concepts. What is an asyncio.Future? A future represents a value that will be available later. It does not run or execute on its own. Instead, some other task or coroutine must set the result of the future by calling set_result. When you await a future, your code pauses until that future's result is set. How does awaiting a future start a task? Consider this snippet. Create_task schedules coro_future to run concurrently. The actual coroutine coro is what runs and eventually calls future.set_result. Your await future waits until coro sets the future's result. Hence, awaiting the future doesn't run the coroutine, it just waits for its completion indirectly triggered by the started task. Keeping a task reference. It's important to assign the created task to a variable, example, task equals asyncio.create_task. This prevents it from being garbage collected prematurely. Why not just await the task directly? You might think of doing. This works but can be inefficient if the coro does other things after setting the future result. Then your code waits for the entire coroutine to finish rather than proceeding once the future is ready. Best practice example. Output. Explanation. We create a future in a task running coro that sets the future result immediately. Main awaits the future to get the result as soon as it is ready. Afterwards, it optionally awaits the task to let the coroutine finish gracefully. Summary. Awaiting a future suspends your code until its result is available. It doesn't intrinsically run coroutines. Asyncio.create_task schedules coroutines to run concurrently. Keep a reference to the created task to avoid premature cancellation. Await the future if only the result is needed. Await the task if you need full coroutine completion. Understanding these concepts helps write more efficient and predictable asynchronous Python code.